Hey everyone, it's You'll Be Blessed here, making it clear, making it plain, opening up the heavens for my teaching is like spring rain. And today we're going to learn how to simplify expressions with rational exponents. Let's go. All right, everybody, let's get started. So we're simplifying expressions with rational exponents, and we're simply going to start with just using a single base for now, because it becomes multi-step, much more multi-step when you have more than one base, okay? So this is a part of a series on exponential functions. Today's objective, we're still going to apply the principles of factoring in order to multiply powers of the same base. Okay, and how are we going to use that? We're going to identify logical patterns, all right? Logical patterns that create simplified forms, okay? So simply by identifying patterns, that is the key. There have been so many ways to teach this topic, and I'm actually just going to teach it the way I best know how to teach it and the way I best understood it, because I actually found this to be quite confusing when I was trying to learn how to reteach this as an Algebra 1 teacher. Okay, so let's get started. So in learning how to teach this, I decided to break this up into simplifying expressions where the rational exponent is less than 1 first, and then teaching about the ones where the rational exponent is greater than 1. So I find that teaching the rational exponents with respect to them being less than 1 is actually easier to understand before you can move on to the ones that are greater than 1. Okay, so here's our first expression. We have 81 to the 1/4 power. Okay, so then in order to solve this problem, or to simplify it, we have to ask ourselves what number multiplied by itself 4 times equals 81. Okay, so the 1/4 lets us know that there is a number that is multiplied 4 times by itself to get 81. Okay, so what we're going to do is we're just going to factor this into things that we know how to factor. All right, so when we factor this, the first thing that comes to my mind is 9 times 9. Notice I keep the 1/4 power on the outside of the parentheses. So I have 9 times 9. But the thing is, do I have 4 factors inside these parentheses? No, I only have 2. So I need to continue factoring until I can figure out what it is that is the 4th root, or what number can be factored into four identical factors, okay? And so if I continue factoring 9 and 9, I get 3 times 3 times 3 times 3, all of that to the 1/4 power, okay? Now, here's how this works, okay? I really think this is the genius behind identifying patterns, okay? And you see, I have 4 3s to the 1/4 power. So then I can ask this question, I can actually base it on this 1/4, okay? I'm going to keep 1 of my 4 factors. So if I have 4 factors of 3, then the final answer is going to be 1 out of those 4 factors. So when I keep 1 of them, the final answer turns out to be 3. So 81 to the 1/4 power is equal to 3. Simple, right? Excellent. Just nod your head in agreement. Let's do it, okay? So again, the reason why I think this is the easiest way to do it is just factor. If you factor, you can logically identify the pattern that allows you to simplify these rational exponents, these expressions with rational exponents, okay? So let's try another one. This time we have 16 to the 1/4 power. So I'm going to ask myself, what number multiplied by itself 4 times equals 16? I don't like to pretend that I know everything off the top of my head, all right? So I'm just going to begin factoring 16 until I get a number that repeats itself 4 times. So when I do that, I get 4 times 4. Okay, 4 times 4 is not 4 numbers. It's not 4 identical factors. So I'm going to continue factoring. And this time I'm going to get 2 times 2 times 2 times 2, all to the 1/4 power. All right. Now I have 4 identical factors. All right. And because I have 4 identical factors, I can continue to successfully simplify this by looking at this 1/4 power. The 1/4 power tells me that I should actually keep one of my 4 factors, just like in the previous problem. Okay. So if I have 4 factors of 2 and I keep one of them, then the final answer will actually simplify to 2. Excellent, right? See how easy that is when you just think about it like that? We're taking factors and we're actually using a rational exponent to actually shrink the number of factors that are in that problem. And that's how we simplify this. Let's look at another example. So we have 27 to the 1/3 power. Again, I know the answer already, but I'm going to pretend that I don't. Okay, so this is 27 to the 1/3. The question I want to ask myself is, what number multiplied by itself 3 times equals 27? So I need 3 identical numbers that when you multiply them together, they equal 27. All right. So I'm going to just factor. What 2 numbers do I know multiply to 27 other than just 1 and 27? Well, I know 3 times 9. So 3 times 9 to the 1/3 power is the same thing as 27 to the 1/3 power. All right. But I'm not done because I need 3 identical factors. So I can continue factoring the 9. So if I factor that 9, I know that 3 times 3 is 9. So this turns into 3 times 3 times 3 to the 1/3 power. All of this to the 1/3 power. Now that I have 3 identical terms, 3 identical factors, what can I do next? I can keep one of the 3 factors. Isn't that easy? Again, so simple when you look at it that way. So if I keep one of those 3 factors, the final answer is 3. And if you know that 27 to the 1/3 is the same thing as 27, the cubed root of 27, you might already know that the answer is 3, but this is the logical reasoning that goes into being able to perform that operation. Okay, a logical pattern that allows you to create simplified forms. All right, so here's another example. We got 64 to the 1/2 power. Okay, now I know this answer because if you know your square roots, because some of you may have studied your square roots before studying this, or you might have not studied your square roots before this, but here's how you would do it. The question I need to ask myself is, what number multiplied by itself 2 times equals 64? So I need 2 identical numbers that multiply 64. And the first thing that comes to mind is going to be 8 times 8. So hopefully by now you get it. Okay, because this is 8 times 8 to the 1/2 power. So then how do I make this next decision, or what is my next decision? Because of the 1/2 power, that means I need to keep half of my factors, or 1 out of 2 of my factors. So when I commit to that, one of those 2 factors takes me down to a single 8. So 8 is the final answer. 64 to the 1/2 power is equal to 8. Now, let's try where we're not dealing with 1 in the numerator. Okay, so the rational exponent is still less than 1, but the numerator is no longer 1. And if you've really been paying attention, you're going to find this just as easy as the previous examples. So if we look at 27 to the 2/3 power, 27 to the 2/3, what question am I going to ask myself? What number multiplied by itself 3 times equals 27? So again, I need 3 identical factors that when multiplied, they give me 27. So when I start factoring, I get 3 times 3 times 3. Okay. So what does my exponent tell me this time? It's now 2/3 instead of 1/3. So what can I do? How do I interpret this exponent, this rational exponent that's less than 1? Well, it simply means I need to keep 2 of my 3 factors. 2 out of 3, 2/3 power. And so the final answer will be 3 times 3. That's 2 factors of 3. We got rid of the third factor. And so 3 times 3 is 9. So 27 to the 2/3 power is 9. All right, let's move on to another one. 16 to the 3/4 power. So what question am I going to ask myself? What number multiplied by itself 4 times equals 16? 4 identical factors that multiply to 16. Next, let's begin to factor. We know from a previous problem that our 4 identical factors are, well, if I factor this is 4 times 4. It's not 4 identical factors yet. So when I factor it, I get 2 times 2 times 2 times 2. All of this to the 3/4 power, all right? So how do I interpret the 3/4 rational exponent? Simple. I'm going to keep 3 out of the 4 factors. Therefore, if I have 4 sets of 2 and I remove 1, I keep 3 of them, that is 2 times 2 times 2. Now notice I get rid of the exponent once I do that, okay? So 2 times 2 times 2 gives me 8. So 16 to the 3/4 power is 8. Excellent. All right, so now let's move on to how do we simplify expressions with rational exponents that are greater than 1. Okay, so now the rational exponent is 3/2. 3 divided by 2 is 1.5. So it's greater than 1. Okay, the numerator is larger than the denominator. So 64 to the 3/2 power. So I'm going to go ahead and demonstrate this first step because I believe this first step is what allows me to simplify this expression with more clarity. Okay, so if I have a rational exponent that is greater than 1, what I'm going to do is just factor out the numerator. Factor the numerator, of the exponent. So I'm going to pull the 3 out, all right, using the power to power of exponents, okay? And so there we have 64 to the 1/2 power to the 3rd power. So now I'm going to just work on my inside first, okay? 64 to the 1/2, 2 identical factors, all right? So what number multiplied by itself 2 times equals 64? I'm looking for 2 identical factors that multiply to 64. That's 8 times 8 to the 1/2 power to the 3rd power. Now that I have 2 identical factors, I can simplify the inner parentheses 8 times 8 to the 1/2 by keeping one of those 2 factors. So when I keep one of those 2 factors, I keep 8, I get rid of the 1/2, and now I'm left with to the 3rd power. Okay, so 8 to the 3rd power is my final answer, and you want to actually go ahead and evaluate that, and you're going to get 512. Okay, so what I like to do is separate out the numerator, okay, and then go back in, reduce or simplify it based on what I know about the exponent being less than 1. And then once I do that, I can increase the number of factors based on that numerator exponent, okay? I know there's a faster way to do this in your brain, but I'm not going to cover that in this video. I think you are smart enough to figure that out yourself, okay? We'll do one more example, and I think you got this. I really think you got this. So we're gonna, again, simplify an expression where the rational exponent is greater than 1. So the 3/2 power again. So 25 to the 3/2 power, okay? So I'm going to begin by doing what? Factoring out the 3, factoring out the 3. I'm factoring out the numerator of the exponent. Now, what do I ask myself? What number multiplied by itself 2 times equals 25? So I need two identical numbers that multiply and 225. We know that's going to be 5 times 5 to the 1/2 power, all to the 3rd power. So now that I have my two identical factors to the 1/2 power, I next have to do what? I have to keep one of my two factors. So I drop one and I drop the exponent, and that's going to give me 5 to the 3rd power. So 5 to the 3rd power, when fully evaluated, is 125. And that is how you simplify expressions with rational exponents that are greater than 1. So I really hope you found that helpful by actually separating and splitting it into rational exponents that are less than 1 and rational exponents that are greater than 1. All right. Thank you for tuning in to You'll Be Blessed Education. I really hope that you were edified and refreshed by today's teaching. And if you were, I could really use your feedback. You can start by first clicking that like button below. Second, you can actually leave a comment below describing how you were blessed by this video. Third, if you know anyone else that would be blessed by this video, you can share it with them. And then fourth, you can subscribe to this channel for future content. So thank you again. This is You'll Be Blessed Education. Be blessed. I am out.